You want to know more about molecular spectroscopy. Is that correct? Yeah. Okay. So are you finding that the lectures are useful to you?
Yes, sir. It's very useful. In the third year BS, in the second year BSc course, we are teaching the small class spectroscopy.
Okay. Okay. So you are teaching them. Oh, I see.
Yes,
okay.
sir. Yes, sir.
So for you, this will be useful to use as a teaching material also.
Yes, sir.
Oh, very good. Thank you. I think that's one of the purposes. Okay. Let me come back to you again. Yeah, go ahead.
Yes,
if you
sir.
have. Yeah, go on. Okay, Dr. Ms. Suchandra, can you hear me? Hello. Okay, I have a third person with the name HWLLD. Can you put your name on instead of you can put your name through the and click your name in the participants list and do a left click or something like. You can add your name. Can you hear me? H2, HWLND, H2, can you hear me?
Yes, I will help them. You need to select audio connection and use the appropriate audio to connect. It's not
no problem. No problem. I'm able to hear you now. Yeah. Okay. Use. Okay.
Yeah, they can put it on the chat. You can type the chat in the chat window is available.
Right on the chat. Okay. Can you put the? Yeah. Tell us a little bit about them. No. But this is a live. They are in the Zoom window, so they should be able to connect to the audio and talk to me directly. Even though it is YouTube, it's YouTube only after 100 participants, right?
Yes, sir. But I cannot see their mic button, sir. I cannot see their mic button. That's why I worried whether they are hearing.
I don't see the mic button of both of them, both Suchandra as well as HW. You must connect your audio to talk to me or send me a message in the chat, meeting chat. Okay. Tell us about yourself, what you are doing and why you are interested in the course. Do you hear me? Please say yes in the chat if you hear me. Oh. Okay, so Dr. Gayatri, would you have any specific question or shall I simply say generally what I think should be part of this course? You need to unmute the mic. Please type your questions, if any of your questions, please type it in the chat more. If you are hearing me, but I'm not able to hear any one of you, okay? Hello? This is an interactive session. This is not a lecture. Yeah. One more candidate has joined, calls himself as Dell or herself. Do you have the audio connected? You need to allow your audio. Hello? Yeah, connect to the audio and speak to the mic if you have. The computer will be able to speak to the. So Chandra, you are not able to write anything or you are not able to connect to the audio? You must, if it is a mobile, you must permit your mobile audio from the settings, mobile settings. Okay, I have one more student, Satya, PG Chemistry. Satya, are you connected on the audio? I don't see the audio button. Hello? No, I'm not able to hear you. Can you type a question? Can you tell us who you are? Where you are studying or where you are teaching? Hello? PG Chemistry, Satya, are you able to hear me? Please say yes in the chat mode. Hello? It's some sound coming from Dell. Yeah, now your audio is connected. Unmute the audio. Yeah, good evening. Good evening. So, Satya, you are not able to connect your audio in the link. You should be able to connect, and yeah, you are. Your audio is on. Please unmute it and speak. Need to unmute the audio. Right now it is muted. Well, you also can speak after unmuting yourself. Anyway, let me explain while you are trying to do. The idea of this course is to provide you with very fundamental, but at the same time, somewhat elementary aspects of molecular spectroscopy. And in the 4 or 6 weeks, which are still remaining, about 6 weeks are still remaining, I hope that you would go through the lectures on the vibrational spectroscopy, elementary, and elementary microwave rotational spectroscopy, and a bit of Raman spectroscopy as well. Okay, these are the 3 topics which are immediately of importance. I don't remember whether I had added nuclear magnetic resonance in this lectures, but let me go back and check my lecture notes later. Sometime next week, I would like all of you to join online, and I'll send a request to all of you again. And you must tell me why you are doing this course and what motivates you to do this online course. Del and Mahesh, can you unmute by now? Are you able to unmute your audio and be able to speak?
Yes, sir, I'm able to speak.
Very good, Mahesh. Yes, I can hear you. So what is your motivation for taking this course?
No, sir, sorry, but actually I'm attending another course along with this chemistry. I'm studying nuclear and radiochemistry right now.
Okay.
So
Where are you studying now?
I'm in Bangalore, sir, right now.
Or in Bangalore, where? You are in a college doing postgraduate or graduate degree? What is it that you are doing?
I completed my graduation in aeronautical engineering.
Okay.
But now I'm attending a course for IoT, for skill development.
Okay, on the course on IoT. Okay, but then this is a chemistry course.
Yeah, sir, I am.
So what is your interest in spectroscopy? Why are you interested? I just wanted to find out something very nice.
So 1 second, I'll put on my headphones.
Yeah, please do. I'm able to hear you. Yeah, I'm able to hear you.
Sorry, sir, I can't hear you.
Okay. Try now. Can you hear me now?
Yes, sir, I can hear you.
Yeah. So what is your interest? Why are you interested in spectroscopy?
Sir, as I'm studying nuclear and radiochemistry, I also like to study on how matter interacts with the electromagnetic radiation.
Okay, so you wanted to know how radiation interacts with matter.
Yes, sir.
Yeah, spectroscopy is the interaction of electromagnetic radiation with matter. And obviously, electric component of radiation has interactions with the dipole moments, electric moments of the molecule. And the magnetic component of the radiation has interactions with the magnetic moments of the nuclei and electron. So, yeah, so that's very nice that you want to know something about it. Del, are you able to
Quite
speak?
interested in this.
Yeah, go on. Again, yeah, go ahead.
Yeah,
Louder.
so while studying, while teaching chemistry, do you teach along with the topics of subatomic levels, what's inside a proton and an electron? Or do you just stop at the proton and electron?
Okay.
Yeah, that's what I wanted to know.
Okay, this is not a nuclear spectroscopy. This is a molecular spectroscopy. So it talks about, yeah, properties of the electrons are important in the electronic spectroscopy as well as in vibrational spectroscopy. Yeah, you will learn a little bit, but I won't teach you the subatomic nuclear molecular systems and what is inside the nucleus. I wouldn't be able to teach in this course, okay? But I will teach you how molecular systems interact with radiation, okay? Through molecular rotational energies or through molecular vibrational energies and so on. Okay?
Yeah, so one doubt I have: what spin in what's electron spin, sir?
What the electron spin is, right?
Yes, sir.
Yeah, electron spin. If you want to understand electron spin, you need to go far deeper into quantum mechanics because there is no classical model for us to understand the electron spin by going into quantum part. Electron spin is purely quantum in nature. So the way we need to understand electron spin, we might need to know a little bit about the field called quantum electrodynamics. So in this course, if I ever use electron, I use the electron spin as a postulate, okay? As a property of the electron.
Yeah,
we don't worry about we don't worry about why that property arises. That we don't worry, but what that property leads to in spectroscopy, how it changes, how it produces spectral lines, and how we can understand electron spin interacting with the other electrons or other nuclei. Same thing with the nuclear spin. So we assume that it is there, and then we see what it is doing with the molecular properties. That's what we are trying to understand. Okay.
Yeah.
Yeah. So Del is the only other person who is not able to speak. Can you connect? Del? Please unmute. Yeah.
Good evening, sir.
Yeah, good evening. Now I can hear you. Yes, go ahead.
So, I'm actually a student from MSc Applied Chemistry, sir.
Yeah, where?
Andhra University, sir. Andhra Pradesh.
Which university? Applied chemistry?
Andhra University, sir.
Andhra University. Oh, I see. Do you know that my MSc was in applied chemistry? You don't? Okay. That was 43 years ago, I guess. 1979. I finished my MSc in chemistry, applied chemistry. But then I moved over to theoretical chemistry, and I have been a theoretical chemist since 1982. So that's almost like 40 years now. So in applied chemistry, where do you use spectroscopy?
Organic spectroscopy, sir. At present, we are having the semester is going on with organic spectroscopy, sir.
Okay.
So this course would be a little bit helpful for me in way more understanding better about organic spectroscopy. So
Absolutely.
I'm choosing this course. Sir.
Yeah, it will be. That will be parts of it where you understand the principles, why the spectral lines are observed. And organic spectroscopy is very important for identifying molecules, new species, and new phenomena of spectroscopy. So that's a very important important application. In organic spectroscopy, they may teach you both the nuclear magnetic resonance, they will teach you mass spectrometry, and they may also teach you infrared and vibrational spectroscopy. I hope those are the things you are studying, right?
Yes, sir.
Yeah, I would imagine that. Yeah, we have a course and we have two very well-known and internationally well-known teachers on the organic applications of spectroscopy. So you can also find out that there is a course like that in the NPTEL, which you may want to do later. Okay. But I hope all three of you are finding, who are here, are finding that the course is useful to you and it teaches you what you are expecting to learn, I hope.
Yes, sir.
Okay, that's very nice. Dr. Gayatri, yeah, you mentioned already. And Mahesh
Sir, I want to learn the. Sir,
Yeah.
Sir, I want to learn the problems in the marker spectroscopy, sir. In the assignment, you have given a lot of problems in this.
Yeah.
So I want to learn those.
Okay.
Mainly, I joined because of this.
You want to know how the problems are solved? Is that what you are asking?
Yes, sir. Yes,
Yeah.
sir. Yes,
What
sir.
I would do after the assignment grades have been published, okay? That is, after your assignments are graded.
Okay.
Right now, the assignments are part of your quiz in the evaluation. So I cannot tell you the answers
No,
now.
sir. No, sir. I am not asking the answers. Just I want to mention the answers where I learned all the. I just watched all the YouTube lessons. This lecture 4 and lecture 3. But I didn't get this formulas in that YouTube lessons. So that's why I'm asking.
But the formulas are there in
formulas.
But the formulas are there in the lecture notes, right? Did you?
No.
Yeah.
I watched all the lecture YouTube, sir.
Oh, there are some things which are not there in the lectures?
Yes, sir. Yes,
okay.
Sir.
Okay. The book for you that you will find everything that you need for this is the book by Banwell. Yeah, is the book Banwell Molecular Spectroscopy. It's a very famous book for you. Okay?
Yes, sir. Yes, sir. Yes,
yeah, you know that book.
Okay, sir.
Banwell is the author.
Yes, sir. I know, sir.
Yeah, you know the book.
C.M. Banwell. Yes, sir. Yes, sir.
If you read my lecture, if you listen to my lectures and also read Banwell once in a while, you see all questions can be answered. Okay.
Okay, sir. Okay,
but
sir.
I will give you a session on how to solve problems next 2 weeks.
Sir.
Something like yes,
okay, sir.
That'll be two or three
Definitely, I will join.
Yeah, I'll do that. Yeah.
Okay, sir.
Because you are a teacher. You are a teacher.
Sir.
You need to know. Okay, Rajalakshmi is still connecting to audio. I hope he's able to connect. Let us see. Yeah, Rajalakshmi, you are welcome to the class, this one online. Can you hear me? Please unmute your mic. Speak after unmuting the mic. Can you hear me? Please type a chat if yes or no, if you can hear me.
So,
yeah, go ahead. Yeah.
Sir, I have a doubt. When we talk about instrumentation, like when we use about instrumentations in this.
Not in this course, because it is a very short 8 weeks course. I won't talk about instrumentation at all. But there is a separate analytical spectroscopy course in NPTEL website.
Okay, sir.
Please also have a look at the chemistry program. There are many courses. There is one analytic spectroscopy which talks about instrumentation.
So
I think this is a course by IIT Kanpur professor, if I remember. I don't know whether it's being offered now, but they are there in the archives. You should be able to see the NPTEL website. And if you type that course title like Instrumentation, Analytical Chemistry, you will get directions immediately. Okay.
So my doubt is.
Let me answer this question next week in the forum, public forum. Okay.
Okay, sir.
I will also put an answer to that. If there is a specific link, I will point out to you. Okay.
Classical mechanics talks about instrumentation or quantum mechanics.
No. This is, see, instrumentation is for measurement of spectral lines. They all work on quantum principles, okay? All instruments, all spectroscopy, all spectrometers, like the infrared spectrometer, the Bruker and the NMR spectrometer, and microwave spectroscopy, all of them work on quantum principles, okay? There is nothing like a classical spectroscopy instrument. The instruments are instruments. You put the molecular samples into the respective sample tubes and then irradiate the sample. You get the spectrum, which is a quantum property. Okay? The instruments are capable of measuring these quantum properties and give you spectral lines. So what they do is they use a technique, almost all of them use a technique called the Fourier transform. The Fourier transform, what it does is it collects electrical signals, molecular signals, as a function of time, and then it converts them into the 1 over the time, that is the frequency domain. So this is a technique which is also programmed in the machine. It's called the Fourier transform, fast Fourier transform method. This is there in all the instruments which are running, like the large scale infrared spectrometer or the NMR spectrometer or the EPR spectrometer, all these machines. These machines do not have a classical signal. That's what I want to tell you. Okay, they have only one property, which is a quantum mechanical property.
Okay, sir. Thank you, sir.
Does it make sense?
Yes, sir.
Okay, yeah.
Thank you, sir.
Yeah, thanks. So I have to also, this is today, I wanted to have a formal introduction with all of you. I mean, you have seen my face in the lecture notes, but then actually I wanted to meet all of you sometime. And please follow through the course material. At the end of the course, after doing all of this, and you are very happy with it, you want to come to IIT Madras, you can always write to me on my email ID. My email ID is already there in the course website, okay? But I will also write it down here. Okay? This is my email ID, mangal@iitm. Please mention that you are a student of this particular course, Chemistry 2. And my other email ID is, I will just give you that, both of them. a@gmail.com. Okay. So you can see both my email IDs in the chat box. Okay. And you can always write to me. If you are nearby and you want to visit IIT Madras and also find out more about the instruments and so on, as a student of this course, I would recommend to the department that you be permitted to come in here and talk to the faculty. And if you are college, you want to bring in the whole institution, your college is MSc or BSc students to IIT Madras, please feel free to write to me. We will schedule a visit to the institute and to our department, and you can see all the spectrometers and other faculty who have also given the course materials in the NPTEL program. Okay. So at any point of time, you can do that. Dr. Gayatri, if you want to bring your students to IIT Madras and you can arrange some local travel to bring them here, we are most happy to have you here for a day and take you, your team, and tell them everything about the department. Okay.
Thank you, sir.
Yeah. Okay. So because there is some other cross program today, what I would do is, let me close right now. It was very nice of you, for all 4 of you, to come and join and talk to me. But we will have one longer session where I would write down some basic steps in solving problems in the next week, sometime online class, most likely around this Friday or whatever, or may not be Friday, some other time. Balaji, is it possible to do it other days?
Yes, sir. Fine, sir.
We can do it, isn't it? So I will schedule a date with all of you. And please join. And in the meanwhile, if there is any question, either send me a mail or raise it in the forum. Okay. I wish you all the best to all of you.
Yes, sir. I think Mahesh wants to say something.
Yeah, Mahesh, please go ahead. Yes, I saw your hands raised. Yeah.
Sir, if you are busy, it's fine right now. I can ask you the next week.
Louder. I didn't hear. Sorry.
If you are busy right now, I can ask him this question in the next session itself. It's fine.
No. We have another session, cross session coming in. Therefore, I need to leave for the next person to take the session. But can you send the question by email to me, Mahesh?
Yeah, sir, sure. Yeah, sir, sure. I'll send it by mail.
Yeah, please send it to me. You know, my email ID is there. Yeah,
Yeah, sir, I noted it down.
please send it and I will reply to you. Okay.
Yeah, sir, sure, sir.
Thank you. Thank you. Okay, thank you. Have a good evening, all of you, and have a good weekend. And continue to study. If you find any mistakes in my lecture, I will be even happier to learn from you and correct them. Okay. All the best to all of you. Thank you.
Thank you, sir.
Thank you. Yeah. Yeah. Bye. I will leave now. Okay.